Valid Palindrome 3. This is a premium hard problem, but it's not that hard, but we can solve it in different ways. So given a string as and an integer k, return true if s is a k palindrome. A string is k palindrome if it can be transformed into a palindrome by removing at most k characters from it. So if we see this string A, B, C, D, E, C, A, here if we remove this second character or first index character B and this E, we get a string A, C, D, C, A, which is a palindrome, and we removed only two characters and K is 2 here. So this is a K palindrome. Let's see how do we solve this problem. So, consider this string A, B, C, D, E, C, A, and here if we remove this character B and E, we get a result A, C, D, C, A, right? So this is a palindromic subsequence. And so if A, B, C, D, A, this is one string we have. How do we check if it is a palindrome or not? We take one index here, one index here at the beginning and end, and we'll see if both are matching or not. If this one and this one is matching, then we can check the rest of the part, this BCD, if this is a palindrome or not. If it is, then we can return this is a palindrome. We'll apply similar intuition here. So for this problem, let's say A, B, C, D, E, C, A. A and A are matching. Our I is currently here, J is here. We have to check from this part if we can get a palindrome or not. If I character and J character is same, we are not removing any character from the string, right? So K will remain same. Next, my I is here, J is here, B and C are not same. Then we have a choice. We can remove one character. Which character do I remove? Either we can remove C or we can remove B, because B and C are not matching. So basically now we will have to check for this part or this part. Basically we'll move I. We'll check for I, J minus 1, this is one condition, or I plus 1, J. If either of these two is fine, is giving a palindrome, then we are good. But in this case, we are removing one element, one character, right? So K will become K minus 1. So let's see how do we solve this. So let's say I will take one recursive function. I'm just writing the pseudo code here. This is valid function that will take three parameter I and J, but also we have to keep track of K, right? We'll see how do we improve the solution, but this is the basic solution comes to my mind directly. We have three parameters. We have to check for I and J J index characters, and we have a K parameter. We can remove at most K characters from it. So at each moment, at each position, if I equals to Sj, then what will return? We'll see if is valid I plus 1, J minus 1, and we haven't removed any character at present, right? So K is remaining same. So we can just return this. Else means I and Jth character is not matching. In that case, we have two choices, right? We have to see if is valid I plus 1 J, and then also we have removed one character, right? So K will become K minus 1. We have one more choice, is valid I J minus 1. Means we have removed one character from the end of the string, and then also K will become K minus 1. We can return if either this is true or this is true, right? Otherwise we can return false. So what will be the time complexity for this solution? So we are going through each I and j position, and at most will have n square iteration in n square recurrence here, and also we have a parameter k, right? So this time complexity here will be n square k. Let's run the code and see how this performs. So let's take one function. In a function I'm taking, that is valid, and here I'm taking I, j and k as parameter. So I is starting at the 0th index and j is starting at the end index, right? And we are trying to increment I and decrement j, right? So when I will cross j or j will cross s or j will cross I, it means we haven't invalidated any choices, right? So we found a solution in this case. So if I greater than j means we can return true. We haven't violated any condition. Now let's see if s of I equals to s of j. That means at the first and last index we found one match. So then we can return is valid I plus 1 j minus 1, and we have found one match, so we don't need to remove any character, right? So k will remain the same. Otherwise we can remove character, right? We can when we can remove character when k is greater than 0. If k has already become 0 means we cannot remove any character further. So in that case we have to return false. So if k is greater than 0, we can do something, but if k is less than 0 or equals to 0 means we cannot do anything. In that case we'll return false. So if k is greater than 0 means we can remove any character. Which character will remove? We can either remove ith character or jth character. So if we remove ith character, we can see if I plus 1, from I plus 1 to j, if there is any match, if there is any solution. Then we have removed one character, right? Will be k minus 1. One more solution will be if we remove the jth character. I will remain at the ith index only, but j will be j minus 1. And in this case also we are removing one character, so k will become k minus 1. So we'll return true if either of this condition is satisfied, right? So this is the solution for recursive function, and we can just return is valid 0, length of s minus 1, and k. K is the number of characters we can remove. Now let's run this. This works, but it will not be that much efficient. It will give TLE. Let's see. Yes, it is giving time limit exception. What we can do is we can use some extra memory. Let's say I am taking one cache and this is a dictionary. So if I, j, k in cache, return cache of I, j, k, and then we have to populate this cache, right? So let's take, this is the result, this is the result here, and this is the result here, and we'll just populate the cache with this result, and then we'll return the result. right? So let's see. This works. One more thing we can do is, instead of just in Python, we can instead of using a cache directly, we can use an inbuilt cache option, that is LRU cache. We can just use this annotator and it will work the same. Let's try submit this. So it's slightly better. So what is the time complexity for this? This will be n square k. Let's verify this. Yep, this is n square k. Now we'll see a better solution. Let's say I'm just calling this recursive function DFS. So in the earlier solution we used I, j and k, three parameters. So the complexity was order of n square k because of this k parameter, right? Do we need actually this k? Without this k, can we solve this problem? So let's see the string once again. A, B, C, D, E, C, C, A. So A and A are matching. We're checking for the rest of the string. And here B and C is not matching. So we'll check if this can return a valid K palindrome or this, right? So seriously, this one is a solution, this part of the solution. So this will give a valid K palindrome. Here also the palindrome, valid K palindrome we can get is either A, C, D, C, A or A, C, E, C, A, either of these two, and both are of length 5, right? So, and what is the length of the whole string? That is 1, 2, 3, 4, 5, 6, 7. So 7 minus 5 is 2, means we have removed 2 characters from this string to make it a valid palindrome. So, and our k is 2. So basically if we just check length of this string minus length of this resultant longest palindromic subsequence we are getting, and if that is less than equals to k, right? If this is satisfied, then we'll get a then we can say this is a valid K palindrome. So how do we solve this? Let's say DFS I J. I'm just writing the pseudocode here. So if I is greater than J, means then we will return 0, because we are starting I at 0 and j as the end at the end of the string. So whenever I is crossing j and j is crossing I, that means we didn't find a valid palindromic subsequence. We can return 0. Otherwise, if s of I equals to s of j, then there can be two scenarios. Let's say if this is the case, this is the smallest string, right? So if this is I and this is j, means these two are matching, then we are getting a the palindrome of length 2. But if we are just checking just the string A and I and j both are at the same position, right, then we are just getting a length of 1. So length is 1 if I equals to j, else 2, right? And let's say consider the longest, consider the large actual string we had, A, B, C, D, C, A, something like that. So if A and A are matching, we have to check it now for the rest of the string. So length plus will be DFS I plus 1 G minus 1, else means these two strings are not matching. Then length will be maximum of, because we want to get a maximum length, longest palindromic subsequence, right? Max of DFS I plus 1 j and DFS I j minus 1, right? So this is the maximum length we are getting. So let's return that length. And when we'll be calling this dfx function, wow, using this I is 0 and j is n minus 1, then we'll just see the result that will give the longest palindromic subsequence length, and we'll just subtract it from the actual string length. You will see like how many characters we have removed. That should be less than equals to k. Let's see the solution. So we are writing a function to get the length of longest palindromic subsequence. Let's call this function something. I'm calling it so I'm taking I and j to pointer only, and I will find the longest length of longest palindromic subsequence from I to j. So if I greater than j, that means we cannot get any longest palindromic subsequence here, right? So we can return 0. If si equals to sj means the first and the last character matches, then we found a match. So let's say that the length is 1 if I equals to j, otherwise 2. If I and j are same, then we just got one length, and otherwise we got two lengths, one at the beginning and one at the end. Now our first and last character matches, but we have to get the result from the rest of the string. So length plus is, let's call it recursively on I plus 1 j minus 1, right? Else means I and j is not matching, right? So in that case length will be longest palindrome as I plus 1 j, and one more option we have is I j minus 1, and we'll take the max of this 2, and that's it. We can just return the length. We'll call this function starting from 0 to length of the string. We can okay, so this will give the longest palindromic sequence length, right? And what we are trying to achieve is whether this string is a k palindrome or not. So what is the length of the string? That is length of s minus longest palindromic sequence length, means this many characters we have removed, but we cannot remove more than k characters, right? So this should be less than equals to k. So let's return that. So yeah, this is fine, but here also I have not used any caching here. It will give daily. So let's use some caching. I'm just directly using LRU cacher, so this will give better performance. So now the complexity is 58%. This is pretty efficient. It will the time complexity here will be order of n square. Let's verify this. This is n square. Now let's see if we can improve this further. So can you use a dynamic programming approach, like bottom-up dynamic programming approach? So how do we do that? Let's try any example like A, B, C, D, E, C, A, the same example I'm taking. So we can start our I pointer here, and will this my J will move here starting from I to here. Next time I will come here and J will move from here, right? And this way when I will reach 0, I will reach here at 0, right? When I for this, and J will point here, right? So that will be my solution. My solution will be dp0 and n minus 1, where n is length of the string. So let's take one dp array. N is basically length of the string. This is a n cross n array or matrix we have taken. Now we are starting our index I from n minus 2 and will reach till 0th index. Now we are starting our j index from I and will reach till n index. Is basically for we are starting I from the end of the string, second element, second last element from the string, and from there only we are just moving j pointer from that I position till the end of the string. And if I equals to z, that means we have only one character, right? So dpi j will be 1. Else if I plus 1 equals to j, means we are getting two characters. Two now I plus 1 is j. Then if I and j are, if si and sj are same, then we'll get a two length palindrome. Otherwise we'll get a one length palindrome for each of the character, right? 2 if si equals to sj, else 1, right? Else if si equals to sj, it means for any length more than 2 and the first and the last index characters are same, in that case we got two length, right? dp of ij will be 2 plus we have to check for dp I plus 1 j minus 1, right? Else first and last index are not same, index characters are not same, then dp ij will be max of dp I plus 1 j or dp I j minus 1, right? Either removing either of the first or last character. So that's it. So dp0 n minus 1, that will be the length of the longest palindromic subsequence in this case, and our whole string length is n, right? So n minus this length, that should be less than equals to k. So we can just return if this is true. So yeah, this works. and this is pretty efficient, 80%. And this also has time complexity in square, but it is much better.